Okay, homework U6, so second year homework 6 on trig and binomial expansion. Question 1, part A, use this identity cos squared theta plus sin squared theta equals 1 to prove that tan squared theta equals sec squared theta minus 1. So here we're going to divide through by cos squared theta for the whole thing. So cos squared theta divided by cos squared theta equals 1. Sin squared divided by cos squared is tan squared. 1 divided by cos squared theta is sec squared theta. And then we just check with the format we're looking for. So we're looking for tan squared to be the subject. So subtract 1 and we get tan squared to be the subject as required. Okay, part B. So here we've got a long equation involving a sec squared and a tan squared. Now because the sec is the linear term that's given and we've got quadratics in sec and tan there, we want to keep the sec, we want to get everything in terms of sec. That linear term is fixed. Get everything in terms of that, so therefore the tan squared here needs to change to a sec squared. Okay, so we can use the identity from earlier on. Kind of gives the game away a little bit. So tan squared theta is sec squared theta minus 1. The rest stays exactly the same. And then just do a bit of tidying up, expanding the brackets and so on. So 3 sec squared theta plus a 4 sec theta. Minus is 2, but then pull that 2 across as well, you get minus 4. Okay, and so we finish with the quadratic in terms of sec, so 3 times sec squared, 4 times sec, minus 4 equals 0. Okay, so that, can that factorise is what you're asking yourself. So 3 sec theta at the front there, sec theta at the front there, and we want things to be multiplying to give the minus 4. The middle term though needs to add to give plus 4 sec, so if we make that a plus 2 we get a plus 6 sec theta there. Make that a minus 2, then we get a minus 2 sec theta there, so 6 sec theta minus 2 sec theta gives us the 4 sec theta we need. Minus 2 times 2 gives us a minus 4 that we need there as well. Okay, so the results from this bucket then, so 3 sec theta minus 2 equals 0, so sec theta itself is 2/3. From this bracket we've got sec theta equals minus 2. Okay, now sec, there's no such thing as an inverse sec on the calculator, so we're going to be looking for to turn it back into sine, cos or tan. Sec then is defined to be 1 over cos theta, so we've got 1 over cos theta equals 2/3. Okay, and then if you take the reciprocal of each of those to get cos theta to be the subject, we can take the reciprocal and we're left with take the reciprocal there and we're left with cos theta equals 3 over 2. Over here similarly 1 over cos theta equals minus 2. Take the reciprocal of both sides and we've got cos theta equals negative 1/2. Okay. Now cos theta equals 3 over 2 we'll have no solutions because 3 over 2 is 1.5, which is greater than 1. You can definitely calculate if you like, but inverse cos of 3 over 2 will not have any solutions, so no solution. Inverse cos of minus 1/2 though will have some solutions, so here we go. Inverse cos of negative 1/2 of 0.5, and that is giving us 120. Okay, but remember we need to, we're trying to solve here between 0 and 360, so we're going to need to try and get the alternative angles for this. So if we do a quick sketch of the sine curve, the cosine curve. Okay, there we go, 360, 270, 180, 90, 1, minus 1. And where are we at? We're at 120 because it's a minus 1/2 here. Dot 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 up. That's 120. Dot 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 up. Okay, so however you use the symmetry there, you're going to get 240. Okay, so one simple way with cos actually is just to say, well, all of that angle there is 120, and therefore all of that angle there is 120. 360 minus 120 gets you to 240. So overall then we've got 120 or 240.